Welcome, space explorers, to the ultimate guide to our cosmic neighborhood, the solar system. Ever looked up at the night sky and wondered what's really out there? Well, today we're blasting off on an epic journey to visit every major player in our celestial family, from the blazing heart of our system to its iciest, most distant reaches. So buckle up, because this is going to be a ride you won't forget. Our first and most important stop is the star of the show, literally, the sun. This isn't just a bright light in the sky. It's the heart of our solar system. The sun is so colossal that it contains 99.86% of all the mass in the entire system. Think about that for a second. Everything else, all the planets, moons, asteroids, and comets, is just the remaining 0.14%. This incredible gravitational pull is what keeps all the planets locked in their orbits, dancing around it in a cosmic ballet. The sun is a gigantic ball of hot plasma, constantly undergoing nuclear fusion at its core. This process releases an unimaginable amount of energy, which radiates out as the light and heat that make life on Earth possible. Without the sun, our solar system would be a dark, frozen, and lifeless place. It's our ultimate energy source, our gravitational anchor, and the reason we're all here. Now, let's begin our tour of the planets, starting with the ones closest to the sun, the terrestrial, or rocky, planets. These worlds are relatively small and dense, with solid surfaces you could theoretically walk on. First up is Mercury, the smallest planet and the one hugging the sun the tightest. Being so close means it zips around the sun faster than any other planet, completing a year in just 88 Earth days. But don't let its speed fool you. Life here would be tough. Mercury has almost no atmosphere to trap heat, so its temperature swings are extreme. During the day, surface temperatures can soar to over 400 degrees Celsius, hot enough to melt lead. But at night, without a blanket of air, they plummet to a frigid minus 180 degrees Celsius. It's a world of incredible contrasts. Next, we cruise over to Venus, often called Earth's twin because of its similar size and composition. Venus is anything but hospitable. In fact, it's the hottest planet in the solar system, even hotter than Mercury. How is that possible? Its secret is a runaway greenhouse effect. Venus is shrouded in a thick, toxic atmosphere made mostly of carbon dioxide, with clouds of sulfuric acid. This atmosphere acts like a super thick blanket, trapping the sun's heat and roasting the surface to a consistent, blistering 465 degrees Celsius. The atmospheric pressure on Venus is also crushing over 90 times that of Earth's, equivalent to being a kilometer deep in our ocean. And that brings us to our home port, Earth. The third rock from the sun is, as far as we know, a unique cosmic jewel. It's the only planet with liquid water flowing on its surface, a key ingredient for life. It's also the only world we know of that harbors life at all, from the smallest microbes to the largest whales. Our planet sits in the Goldilocks zone, a perfect distance from the sun where it's not too hot and not too cold, allowing water to remain liquid. Our atmosphere protects us from harmful solar radiation and keeps our temperature stable. It's a delicate, life-sustaining balance that makes Earth a true oasis in the vastness of space. Our last stop in the inner solar system is the famous red planet, Mars. Mars gets its distinctive reddish hue from iron oxide, or rust, covering its surface. It's a cold, desert world with a very thin atmosphere. While it's not the bustling planet of science fiction just yet, it's incredibly fascinating. Mars is home to some of the most dramatic geological features in the solar system, including Valles Marineris, a canyon system that would stretch all the way across the United States, and Olympus Mons, the largest volcano ever discovered. This shield volcano is nearly 3 times the height of Mount Everest. We've sent numerous rovers to explore Mars, and evidence suggests it was once a warmer, wetter planet with rivers and possibly even oceans. The search for past or present life on Mars continues to be one of the most exciting quests in modern science. Leaving the rocky inner planets behind, we now cross a significant boundary, the asteroid belt. This is a vast, donut-shaped region between the orbits of Mars and Jupiter. It's not the crowded, chaotic mesh you see in movies. The asteroids are actually very far apart, but it is filled with millions of rocky fragments, ranging in size from tiny pebbles to Ceres, a dwarf planet nearly 1,000 kilometers in diameter. This belt is essentially leftover debris from the formation of the solar system that never quite managed to form a planet, thanks to the immense gravitational influence of our next destination. Get ready, because things are about to get massive. We are now entering the realm of the gas giants. These outer planets are enormous worlds composed mainly of hydrogen and helium, with no solid surface to stand on. First, we encounter the undisputed king of the planets, Jupiter. Jupiter is a giant in every sense of the word. It's so big that all the other planets in the solar system could fit inside it. Its sheer size gives it a powerful gravitational field that has shaped the solar system, protecting the inner planets by slinging dangerous comets and asteroids out of harm's way. Jupiter is known for its beautiful, swirling cloud bands and, most famously, its great red spot. This isn't just a mark, it's a colossal, anticyclonic storm, wider than the entire Earth, that has been raging for at least 400 years. Jupiter also has a mini-solar system of its own, with at least 95 moons, including the 4 large Galilean moons, Io, a volcanic world, Europa, with a hidden subsurface ocean, Ganymede, the largest moon in the solar system, and Callisto, a heavily cratered body. Our next stop is arguably the most beautiful planet, Saturn. Famous for its breathtaking system of rings, Saturn is a true celestial icon. While other gas giants have rings, Saturn's are by far the most spectacular and complex. They aren't solid. They're made of billions of individual chunks of ice and rock, ranging from dust-sized particles to pieces as large as a house. The rings stretch out for thousands of kilometers but are, on average, only about 10 meters thick. Like Jupiter, Saturn is a massive ball of hydrogen and helium and has a large family of moons. One of its most interesting moons is Titan, which has a thick, nitrogen-rich atmosphere and lakes of liquid methane and ethane on its surface, making it one of the most Earth-like, albeit in a very alien way, worlds we've discovered. Venturing even further out, we reach the final 2 planets, the ice giants. These planets are still massive but are different from the gas giants. They have more ices, compounds like water, methane, and ammonia in their interiors. Our first ice giant is Uranus. This planet is a real oddball. Its most unique feature is its extreme axial tilt. While most planets spin like tops as they orbit the Sun, Uranus is tilted on its side, rotating at a nearly 90-degree angle. It basically rolls along its orbital path. Scientists believe this bizarre orientation might be the result of a massive collision with an Earth-sized object early in its history. This tilt leads to some of the most extreme seasons in the solar system, with each pole getting 42 years of continuous sunlight followed by 42 years of complete darkness. Uranus is a faint blue-green color, caused by methane in its atmosphere absorbing red light. Finally, we arrive at the last official planet in our solar system, Neptune. This deep blue ice giant is the most distant planet from the Sun, orbiting at an average distance of 4.5 billion kilometers. Because it's so far away, it receives very little heat, yet Neptune is a surprisingly dynamic world. It has the fastest and strongest winds in the entire solar system, with supersonic gusts reaching speeds of over 2,000 kilometers per hour. These incredible winds whip up giant storms, like the Great Dark Spot, which was a huge storm system similar to Jupiter's Great Red Spot, observed by the Voyager spacecraft in 1989. But our journey doesn't end with Neptune. Beyond the planets lies the Kuiper Belt, a vast, icy frontier, similar to the asteroid belt, but far larger and more massive. This region is a graveyard of frozen remnants from the solar system's formation. It's home to countless icy bodies and several dwarf planets, including the most famous one, Pluto. Once considered the 9th planet, Pluto was reclassified in 2006. It's a complex and fascinating world with mountains of water ice, vast nitrogen glaciers, and a thin atmosphere. The Kuiper Belt marks the beginning of the end of our Sun's direct influence, a cold, dark region at the edge of our home system. And there you have it, a grand tour of our solar system. From the fiery Sun to the icy depths of the Kuiper Belt, we've seen rocky worlds, gas giants, and icy oddballs. Each stop on our journey has revealed a unique and wondrous world, reminding us just how diverse and incredible our cosmic neighborhood truly is. Space is filled with mysteries waiting to be solved, and our solar system is just the first chapter in an infinitely larger book. Thank you so much for joining me on this incredible voyage. If you enjoyed this journey through the cosmos, don't forget to hit the like button, subscribe for more space adventures, and let me know in the comments which planet is your favorite. Until next time, keep looking up.